Okay, we have a lot to cover here. Uh, this has been a huge rewrite. Um, I have completely rewritten the solver, which is what determines what sockets can connect to other sockets. Ground up rewrite should be a lot more robust, and it offers a lot of future proofing on what I can do with other things in the future, and has enabled me to do a lot of things that I will kind of tangentially touch upon in this. For a brand new user, or a relatively novice user, I guess, a couple notes compared to my last video. I have changed the colors of some things again, and some categories have moved around. Sorry, this just makes a lot more sense. Hopefully, this will settle soon. What you probably are thinking of as what I had previously called arrays are now called layouts. So like you have your polygon layout instead of polygon array, or your repeated layout, or there's a couple others. But those are now called layouts because they take shapes and they lay them out. It's just a lot more sense. The other reason why I've named them that is because now there is a true concept of an array. So, for example, you have an angle, right? We all know what those are. And by the way, you can actually use different units for angles now. So you can like see 3 radians, or 2 turns, or 0.25 turn. Neat. But deg is the default. So degrees. So you have angles, and now you have an angle array, which is to say a bunch of angles all bundled up into one value. And there are a ton of things that can access and play with arrays now, and we'll get into some of that, but suffice to say, this opens up a lot of doors. Let's see. I've also added a new data type and have shifted some things around, and that is the point. You might know it as a vector, sort of. And it's basically what it is a vector. But the way you create a point, if you're familiar with how they used to work in transforms or positions of shapes, it's that. So you can have like a line. You have a start point and an end point. Well, those are now points. You don't lose any fidelity when it comes to being able to manually input them. You can still do radial or Cartesian, but if you want to parameterize any subset of those, you'll need to break it out into a point constructor here. So just be aware. Anything that you load in should automatically create those, so that won't be a problem, but like just an FYI. But now, because now point is a solid data type all at its own, you can do vector math on them. So you can get like distances and dot products and whatnot without having to do complicated math. There's a whole bunch of point related operators in here now. So that's one thing. And of course, because there's a point, there's now also a point array, which we'll touch on in a minute. So collection of points. So yeah, that's the thing. What else? I think that's pretty much it as far as the changes go. Yeah, pretty much like all your transforms, your points, yeah, are first class citizens there. So that's the thing. Now, on to the fun thing. You can do for loops now properly. You can iterate over arrays. And this is sort of like a sequence, but not quite. You'll see these 2 nodes here that share this dotted blue-ish line. This is a for loop. In fact, this is a for map loop. And the way this works is you give it an array of something, and you attach a for each to a map or a filter. There's a couple other ones that let you pipe these together, and you take the each, which is on each member of the array while doing the loop, this value is going to change. So you say, okay, for each point, I'm going to feed this into the endpoint of a line. And I've got the other point here is just a constant. So in this case, I know that there are 7. Yeah, there are 7 members of this array here. So it's going to create 7 lines going from this constant to whatever point is coming into the for each loop. And that's going into a compose layer so I can map it out. And then the map gathers up all the results of these on each loop and spits it out into its own array. So there are 7 shapes or layers in this array. And I just pipe it into there to get it into the result. So that's your red lines. So now, like I said, you can iterate over arrays and you can filter them, which we'll get to in a second. Excuse me. And there's now another layout, like radial or polygonal, but this just takes an arbitrary array of points. You can think of array as a list of points, an array of points. And basically this just says, okay, at each of these points, just draw me a gold circle. And that's what these are. Now, there's a couple different ways you can create arrays. Now, you could, just create a point array and type them in manually. But what I've done here is I've kind of done some jiggery pokery. And that kind of goes into this gather, filter, and this whole thing here. And I'm going to explain this from the other side. In the last release, I did a spirograph, which is this blue knot shape. You can do all sorts of fun things with that. So, like, yeah, it's a spirograph. You used to play with these as kids, I'm sure. And I've just got this into here so I can turn it off as I want. But so the spirograph does this knot shape, and this guy here takes in a path from the spirograph in this case and creates an array of points, and each point is an intersection. So like it is technically listing out a point for any time that this path crosses itself. Now you'll see that only some of these have gold dots, and that's what this whole block here is. And this is probably not an ideal way to do this, but is just kind of what I threw together. So what I've done here is we have another loop start, a loop initiator. And this is called for n. Now you'll see on these from crossings there's a point count, and this just outputs an integer saying how many crossings are there. It doesn't list out the points, that's what this points does, but this just says how many are there. Now the for n loop initiator, what that does is you give it a count. How many items do you want in this array? And it will just create an array of integers internally. And it will feed it into an each. The first time it'll be 0, the second time it'll be 1, the third time it'll be 2, because I zero index arrays, because I am sane, mostly. And so on each iteration, on each step of the loop, it's going to output an integer, 0, 1, 2, like I just said. And what I'm doing here is I'm kind of piping that into a random seed generator. I'm not going to get into the specifics on this, but basically this whole block right now, as configured, lets me generate a stable but pseudo-random number from 0 to 100. That's basically what this is doing. I can hit generate and it will change the seed, but the source, which is the one that keeps incrementing as the loop goes on, will be stable. So that's basically what I'm doing. So random number on each loop, 0 to 100. I'm then doing a less than comparison, and I'm comparing it to 55. So if this random number from 0 to 100 is less than 55, this is false. Otherwise, it's true. And that's where the magic happens. So we have an array of 0 to 10. In fact, the array is literally 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? What filter does is it basically says, okay, for each loop, what am I keeping? And that's what that Boolean is. So when this Boolean is true, it will keep that member of the array. If it's false, it'll kick it out. And that creates a new array. And in fact, kept indices and kept are the same, but whatever. These are your primary outputs of that. So this is, the members of the incoming array that passed the filter. And this is the members of the array that didn't pass the filter, in case you need either one. I'm going for kept indices. In fact, in this configuration, kept and kept indices are exactly the same. But because I'm using gather, which I'll explain in a second, I decided to keep it the same here. So this whole loop is basically give me an array from 0 to 9 and get rid of half of them randomly. Just pick roughly half of them and just toss them out the window. So I might have like 1, 3, 4, 7, 8. Okay? So what this does, this gather, is it takes in an array, and this is from our crossing, so this is all 10 of those crossing points, and it says, okay, given that array, give me all the members of that array whose position is in this array. So we filtered out this 0 to 9 to say 0 to 7, 8, 9. What this does, it says, okay, give me the 0th, the 2nd, the 7th, 8th, and 9th element. Bundle that up into a new array, a condensed array, and that's what it outputs. That's what gather does. It gathers things from an array using a list of indices. If this is going over your head, I don't know. I don't know a good programming book. I learned the hard way. Yeah. Anyways, so we have this this output, which is our filtered and gathered list of arrays, or list of points rather, array of points, and that is feeding into this for each loop, which is guiding our lines, and it's also feeding into our scatter layout. That's what determines the position of these lines and the positions of these gold circles. So basically, you can do arbitrary for loops now, which is a very long-winded way of me saying that that's what's going on. But this unlocks a lot of potential, I think. It's very powerful. Known limitation, I have not figured out how I want to do reducers yet. If you know what those are, you'll go, oh, dang. But, I'm working on it. Some other fun things you can do, you can pick out a single member of an array given at an index. So like if I want to pick out, I don't know. Let's go to the first index of this kept indices is 2. So you can pick at, pluck out a single array or a single member from an array. And indices are always negative capable. Why is that 13? That shouldn't be. How is that 13? That's. What? I don't know why that's 13. That's weird. There should not be more than 10 in here. Unless. No. Okay. That's a bug. This is why I'm not releasing this tonight. So that's what that should do. I'll look at that. You can filter, you can run a for loop, you can run a for n loop, you can inject a value. So like given an array, You can say, I want to add another element to that array, another member of that array, after the last element. That's what -1 means, is last. Or say before the first. So this is unshift. This is push. You can do the same thing with pluck, or the opposite thing with pluck. Give me the array, but drop off the first element and give me the remaining. You can do -1, which is your pop operation. You can do slices, you can do splices, and you can even shuffle them. So like if you just want to randomly sort the arrays around, there you go. Go nuts. Oh, looks like I got some formatting issues. These labels shouldn't be this small. I'll have to go through that. Oops. So yeah, lots of fun things coming. There's even more. I haven't even gotten into the vector math yet, but like if you know how that works, then you know how that works. All the things that I've just mentioned get inputs and outputs for your subgraphs or your custom nodes, subgraphs, whatever you want to call them. There's a debug thing that I don't know will survive. In fact, this will actually tell us what the heck is going on with this set of points here. So we input that. Why are there 14 items? There shouldn't be 14 items. There should be 10. Oh, that's weird. That would explain why there is... That's 14. Oh, I'm an idiot. I get it now. It's not 10, it's 14. 10 is what the value was before this got disabled because there's a pipe there. That's why that's lying. This 10 doesn't actually mean 10 coming in. Okay, now I'm happy. I need sleep. Bye!